have you ever wondered how a tiny device can cause massive devastation? Welcome to the world of nuclear bombs. It all began with the discovery of atomic energy. This was a breakthrough that changed the way we understand the world around us. This energy, found at the core of every atom, held an immense power waiting to be harnessed. In the early 20th century, scientists began to unravel the mysteries of the atom. They discovered that the energy released when an atom splits could be harnessed for practical use. However, it wasn't long before this groundbreaking discovery was exploited for more destructive purposes. During World War II, the race to develop a weapon that could harness this atomic energy began. This led to the creation of the first nuclear bomb, a device that could unleash a level of destruction never seen before. Thus, the nuclear bomb, a deadly weapon of mass destruction, was born. Now that you know where nuclear bombs come from, you might be wondering, how do they work? Well, the answer lies in the realm of nuclear physics, specifically a process known as nuclear fission. In nuclear fission, the nucleus of an atom, usually uranium or plutonium, is split into two smaller parts. This splitting releases a tremendous amount of energy in the form of heat and light. But it doesn't just stop there. The process also releases additional neutrons which can go on to split more atomic nuclei, triggering what we call a chain reaction. Imagine a room full of mousetraps, each loaded with two ping-pong balls. If a single ball is thrown into the room, it triggers one mousetrap, which then releases two balls that trigger more traps. This chain reaction continues, with each trap setting off more and more until the room is filled with bouncing balls. This is a pretty accurate, albeit simplified, analogy for how a nuclear bomb works. The energy released during fission is what drives the explosion of a nuclear bomb. To give you an idea of the scale, a single pound of uranium undergoing fission releases energy equivalent to over 17,000 tons of TNT. So, the secret behind the destructive power of a nuclear bomb lies in the science of nuclear fission and chain reactions. So, what happens when a nuclear bomb explodes? Well, let's dive right in. The immediate impact of a nuclear bomb is an intense burst of heat and a shockwave that obliterates almost everything in its path. This is followed by an influx of dangerous radiation that can cause severe burns and radiation sickness. But that's not all. The heat and blast also ignite fires that can burn for days, creating a deadly cloud of smoke and dust that blocks out the sun and can lead to a nuclear winter. This would result in severe global climate changes, affecting agriculture and leading to widespread famine. Moreover, the long-term effects of a nuclear explosion are equally horrifying. The radiation can cause cancers and genetic mutations, affecting not just those who survive the blast, but also their descendants, possibly for generations. The devastation caused by a nuclear bomb is not just immediate, but can also last for generations. To summarize what we've learned today, we've journeyed from the birth of atomic energy to how this potent power was harnessed into the creation of nuclear bombs. We've delved into their complex workings and witnessed the profound impacts they can unleash. Yet, amidst the devastation lies a reminder that nuclear energy, when wielded responsibly, can also be a force for great good. Remember, while nuclear energy has the potential for great harm, it also has the potential for great good if used responsibly. Thanks for joining us today, and stay curious.